All right, for today's explainer, we are diving deep into a project that's trying to do something, well, kind of nuts. It's about rebuilding our world's infrastructure from the ground up. The whole idea is to move away from these fragile global grids and build self-sufficient sovereign communities. This is the vision of DeReticular, and it all kicks off with one really radical idea: the death of the line. This is the core philosophy, the big idea behind everything DeReticular is doing. Their argument is that the very lines that define our modern world, power lines, supply chains, even the data cables under the ocean, they're actually these massive, outdated points of failure. So, if the line is the problem, what's the alternative? Let's get into it. So, DeReticular's entire mission is really built around answering one huge question. What if we could build infrastructure that just couldn't fail in the same way? What would a world without all these fragile lines even look like?
This slide just lays out the whole problem perfectly. On the left, you've got linear fragility. That's our world right now, where a single break in a very long chain can cause this massive cascade of failures. But on the right, that's the vision: spherical resilience. Instead of one long, fragile line, you have a whole network of independent, self-sustaining nodes that can just operate on their own if they need to.
And the brain that makes all of this possible is a piece of software called RIOS. That stands for the Rural Infrastructure Operating System. The best way to think of it is as an AI-native civilization in a box. It's designed to manage one of these sovereign nodes, orchestrating everything from local energy and data to logistics, all completely off-grid. But as you can probably guess, this creates a huge new problem.
Okay, so if you're in this new decentralized world with no central authorities, no banks, no governments to verify things, how in the world do you trust that the data you're seeing is real? I mean, if some solar farm out in Uganda says it produced 10 megawatts, how do you know someone didn't just type that number into a spreadsheet?
This is the absolute heart of the technical challenge. How do you prove that a piece of digital data actually corresponds to a real-world physical event? DeReticular's solution is pretty brilliant. You anchor trust not in software and not in human reputation, but in the physical hardware itself.
So let's walk through how this works. First, a physical event happens. A sensor takes a reading. Second, and this is the magic, before that data goes anywhere, RIOS verifies the actual hardware device using something called radio frequency fingerprinting. It's basically listening for the device's unique, unspoofable radio hum that's created by microscopic imperfections from when it was made. And finally, if the hardware checks out, a special chip called a TPM 2.0 signs the data with a private key that is literally burned into the silicon. It can never be extracted.
And all of this leads to this really powerful concept, a hardware root of trust. In this model, trust isn't based on a password you can steal or a company's promise. It's based on physics. The network believes the data because it can mathematically prove that it came from one specific, physically verified machine. And this illustrates the outcome perfectly. You essentially get an automated notary. The network isn't trusting a person sitting at a keyboard, it's just verifying a cryptographic signature that could only have come from one specific machine in the entire world. The machine itself is notarizing the data. Okay, so now the data is real, but where does it live?
Right, so once you have this physically verified data, it needs a home. And you can't just stick it on a normal cloud server, because that would just reintroduce a central point of failure all over again. It needs a special kind of decentralized network. And what RIOS uses is this really fascinating dual-stack approach. To pull this off, RIOS uses two different versions of the Freenet protocol, and each one has a very different job. On one side, you've got Hyphanet, which is the legacy, time-tested version, and on the other, you have the new Freenet, which has the codename Locutus, and it's built for speed and constantly changing data.
Honestly, the best way to think about this is just like your computer. Hyphanet is the permanent, censorship-resistant hard drive. It's where you store stuff that doesn't change much, like equipment manuals or community websites. The new Freenet, Locutus, is the real-time processor. It's handling all the dynamic data, that constant stream of sensor logs, the current state of smart contracts. And it does it all without the crazy transaction fees you'd see on a typical blockchain.
So, we've seen this massive industrial vision, right? From resilient power grids all the way to automated notaries. But what's so cool is that this technology isn't just for big industry. The decentralized web protocols it's built on, well, that's something you can start exploring right now. And this is where it all comes home, bringing this huge concept down to a personal, actionable level.
How can you start building your own sovereign desktop and actually tap into this world? Well, the very first step is picking the right operating system.
So we did a bit of research, and we looked into various Linux distributions to find the best starting point. And what we found is that while there are some great privacy-focused systems out there, like Mofo Linux, which actually used to include Freenet, there's no perfect out-of-the-box solution. As of 2026, there isn't a mainstream distribution that gives you both a really user-friendly desktop, like KDE Plasma, and the full Freenet suite already installed.
So what that means is that the best path forward, really, is to build it yourself on a solid foundation. And for that, Kubuntu is the ideal choice. It gives you that awesome, super customizable KDE Plasma desktop, and it's all built on the rock-solid, widely supported Ubuntu base. You really get the best of both worlds, user-friendliness and stability. And here's the best part. You can get started in about 5 minutes. I'm not kidding. First, just install the latest Kubuntu long-term support release. Second, pop open a terminal and install Java, which Freenet needs to run. Third, run the Freenet installer with one simple command. And finally, you just open your web browser to the local address and bam, you're in. It really is that straightforward. So, we've gone from this huge vision of a world without grids all the way down to a command line on your own desktop. The tools are out there, they're accessible, and they're waiting. So I guess the only question left is this. Now that you can connect, what are you going to build? What will you discover? Thanks for tuning in.